When you first install Proxmox, the setup process will pick out a single interface card from your computer and then assign that to be the management interface. But for network redundancy for servers, typically what happens is two physical interfaces are bound together, and then VLAN tagging is used to give the hypervisor as well as the virtual machines access to multiple VLANs. So how do you configure Proxmox with network redundancy and support for VLANs? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now I'm going to assume that you've already installed Proxmox and that you've got remote access to it through a web browser like I have here. In which case the first thing we're going to do is to take a look at the existing network configuration, or at least what the actual installation process does. So over here in the left hand pane, I've only got one server to pick from, but I'm going to pick that one, which I've called PDE1. And then down here where it says network, just below system, I'll click on that. Then this gives me a graphical overview of the actual network setup. Now this particular computer has two physical interfaces, and during the installation process, Proxmox, it asks which management interface do you want to use. Now the default was ENP0S25. What I could have done was I could have asked it to use this one instead, ENPS70, but I just left it at that. It also asked me what IP addressing do I want to use, and that's what I've set up here. So what Proxmox has actually done then is to create a Linux bridge called VMBR0. It's assigned this interface to the bridge, and it's assigned the IP addressing to the bridge. Now during that installation process, it didn't ask me, do you want to bind these two physical interfaces together? And yet that's sort of like a typical design for hypervisors. You would have two physical interfaces, usually high capacity interfaces. You bind them together, and then what you have are virtual interfaces within there. So you would have a virtual management interface, a virtual interface to get access to storage and so on. If you want a dedicated management interface, that's usually an ILO card, for example, something that gives you dedicated management access directly into the console, into the BIOS of the actual physical computer itself. You can actually have a dedicated management interface like this, but it's a bit unusual. It's kind of overkill, I'd say, unless there's some special thing you need to do with that management interface. But usually in most hypervisors, you would take two network interfaces, bind them together, put those into the actual virtual switches this is a representation of, and then you would actually start carving this up to give the hypervisor access to various VLANs using virtual interfaces, basically. Now at the moment, this bridge, as it's called, a Linux bridge, it's not VLAN aware either, so there's quite a bit of work I need to do here. Now it is possible to do all of that through the graphical user interface. It's just going to take a lot more time to do it, especially because the IP addressing is assigned to the actual bridge here. We want to be able to create a new VLAN interface, specifically in our VLAN for management purposes, and reassign the IP addressing to that. And the easiest way to do that is through the actual shell, if you will. There's an option here to connect into the operating system by just clicking on shell, or you can actually just get a remote SSH session. So what I'm going to do next is to literally reconfigure Proxmox to create a bonded interface, to use that bonded interface on the Linux bridge, and to reassign the IP addressing to a new virtual management interface we'll create. Now because Proxmox here is going to allow me to do copying and pasting through this web browser, if I connect in through the shell, I'm going to use that method to get access to the command line. So I'll click on shell, and then that takes us straight into the command line, logged in as root. As you can see, we're using Debian Linux. So I'm going to change over to /etc/network, which is where our configuration file is. And I'm going to take a backup copy of that file, in case I need something to revert back to. And then I'm going to edit the file. So what we've got here is a loopback interface, a physical interface, a configuration for the bridge, and then our other physical interface. So I'm going to make a space here because what I want to do is I want to actually move this line up to there. So I'm just going to copy that line, paste it into here. Let's go back down there and I'll just delete that line. Now, our goal here is to take these two physical interfaces and bind them together. What we do with them depends on our network infrastructure, you know, what we actually want to achieve here. But I'm going to paste in some lines here to create a new logical interface called a bond interface. And I've given this one a number of 0, so this is bond 0. You can give it a different number if you like, it's entirely up to you, but traditionally in Linux things tend to start as bridge 0, bond 0 and so on. So we've defined our bond interface and we said we want it to automatically start, and then I've got a line here to tell it which physical interfaces to use. So those are the two interfaces we've got defined up there. The name of those interfaces are going to vary depending on the actual hardware you've got, but that's what mine two are. And one thing I'll point out is that you will want to use an even number of interfaces. If you're going to be doing load balancing, for example, on physical interfaces, the algorithms don't play well with an odd number. So if you've got 4 interfaces and one breaks, then that's fine, it'll still work with 3 interfaces, but you do want to get back up to those 4 interfaces. You don't want to leave it permanently stuck with 3 because the algorithms aren't as efficient then. The next line we've got is to do with the failure detection rate. Proxmox's example is using 100 milliseconds like I've got here. So for the vast majority of networks, that's fine. If you make it lower, you're going to make the detection more aggressive. So it's going to depend on your computers, your network infrastructure as to how it copes with that. So it's entirely up to you if you want to lower it. If on the hand you find it's unstable, then you might want to increase it. It's one of these things like you might want to fine tune, it depends, but to be honest, 100 milliseconds is really quick for the typical network anyway. So in my case, I'm just going to leave it as is. Now there is some more configuration that needs to be done on this bonded interface, but I'm not going to do that yet, simply because it really depends on your requirements, it depends on your network capabilities. Now the rest of the configuration is going to be the same no matter what we do with that interface. So I'm going to cover the actual bridge configuration, the rest of the work that needs to be done on that, and then we'll come back to finishing off the bond interface in 2 separate sections. So the next thing I'm going to do is create a VLAN interface specifically for Proxmox to use. At the moment down here we've got our bridge, and as you can see it's an interface has been defined on it essentially that's got an IP address, and what it means is there's actually no tagging going on. There's no reference in here to say this belongs to VLAN 100 for example, or VLAN 200. It's set up as if it was a dedicated management interface, which is what we don't want. We want to take advantage of 2 interfaces, and we want to be able to create lots of logical or sub-interfaces, each in different VLANs, for Proxmox to tap into different VLANs. So in this case, I've created an interface called VMBR0.100. So the VMBR0 refers back to the bridge that we've got here. The dot 100 it says that this is a sub-interface and it's in VLAN 100. Now, there is different conventions that you can do to configure that. I'm just familiar with that strategy because I'm used to configuring routers and layer 3 switches, for example. So to me, it comes out as being a sub-interface. In Proxmox, it's a VLAN interface, and it's one of the ways you can define them. But that's all we need to define our logical interface so that Proxmox will have access to 100. And what it means is that going forward is that Proxmox, if it needs to access 192.168.100 as the network, this interface is in that network, and it knows now to actually tag the traffic that gets sent to the switch with a VLAN ID of 100. Likewise, when traffic comes in from the switch with a tag of 100, Proxmox has an interface now in that VLAN, and it'll be able to look out for that VLAN tag. So because we've moved, or more defined an IP address up here that matches this one, we need to take those 2 lines away. So I'm just placing the cursor down on this line so I can hold down the Shift key, press the up arrow twice, hold down the Control key and press K to delete the 2 lines. And because we're no longer defining an IP address on this, I'm going to change this over to be manual It's the same as the rest. The physical interfaces are set to manual. The bond interface is set to manual. It's only where we're defining an IP address that's going to, where we define an interface that needs an IP address that's either defined statically or needs DHCP, that it's going to be different. Now, another thing that I'm going to have to do is to change the bridge port here. This tells the bridge which interfaces to actually use. So before it was referencing this one single physical interface, we actually now wanted to use the logical interface. So the idea is that traffic gets sent to the bridge sends it to the bond, and then the bond will decide which physical interface to send it to. And vice versa, when traffic comes in a physical interface, it gets sent to the bond, and the bond has the traffic, it'll send it off to the bridge. And then if it's destined for this virtual interface, the bridge will pass it off to that. If it's for a virtual machine, the bridge will pass it off to the virtual machine. The last thing I need to do is add in 2 more lines here. Now, these are to make this bridge VLAN aware. It has to be VLAN aware to be able to do the VLAN tagging. So pretty straightforward definition. I mean, there's even a tick box that you can do within the graphical user interface for that. Another thing we want to set is the range of VLANs that we're willing to accept on this actual bridge. Now, if we go by the example that they've got, they're going from 2 to 4094. Now this makes sense because 4095 is a special VLAN, especially amongst hypervisors. So they've removed that from the list of VLANs that the actual bridge is willing to accept. The reason we have limitations, it's part of security really. The idea is least privilege. If somebody doesn't need access to a specific VLAN, you don't give them access to a VLAN. Now, in our case, what we're doing is we're kind of making the administration simpler really here. The plan is that we make restrictions of what VLANs can be used on the actual switch, the physical network switch. And then we just leave Proxmox, for example, with access to all the potential VLANs we could be using. That way we don't have to configure both Proxmox and the switch every time we need to provide access to a specifically new VLAN. Now, so for that reason, as I say, we've got this complete range of all potential VLANs. We've removed 4095 because it's a special VLAN, and we've removed 1 because it's a best practice not to use VLAN 1. VLAN 1 is typically the only VLAN that a switch knows out of the box. I mean, you'll tend to find in offices, for example, bridges might be just left open on a desk, for example, or on a cabinet that's easily accessible. Might be in a reception room where there's not always somebody there. In which case, you don't want to have this potential risk of somebody being able to simply plug a computer into a port and being able to get access to other computers on your network. So the best practice is do not use VLAN 1. Similarly, Cisco switches, for example, they actually use VLAN 1 to exchange information between each other. So it's especially important on Cisco switches to not use VLAN 1 because you don't want the risk of computers being able to get access to that information that the actual switches are passing between each other. So in this case, it makes a lot of sense why they're going from 2 to 4094. Now, in my case, I'm actually going to drop 2 VLANs from the end. You can mix and match this as you see fit. You can use other VLANs if you like for this. You might want to just keep it at 4094. It's entirely up to you. But because I've been using Cisco switches that long, I'm now used to having what's called an unused port and an unused VLAN. The idea is that if you've got switches out there and some of the ports aren't used, you put them into an unused VLAN. In other words, you don't leave them in VLAN 1, you don't leave them in an actual production VLAN. You don't want the risk of somebody coming along and getting access to a VLAN they shouldn't do. So by putting them into an unused VLAN, they can't get anywhere, they can't get access to anything. So that's one of the reasons I need to drop 1 VLAN. The second VLAN I need to reserve is for what's called a native VLAN. Now, when you create trunk ports, we're going to be using 802.1q tagging to do this. Now that has a special VLAN called a native VLAN, and in the 802.1q configuration, you have what's called an untagged VLAN, or at least a way to deal with it. The idea is that if you've got a computer and it's plugged into a trunk port, if it sends the traffic without a tag, the switch needs to know what to do with it. And for that reason, you have a native VLAN. So the idea is that when the traffic hits the actual switch, if it doesn't have a tag, the switch assigns it to the native VLAN, but you don't want that native VLAN to be in use anywhere on your network. You don't want somebody to be able to send untagged traffic and get access to places they shouldn't be. So it's always recommended for that reason to have another VLAN set aside, which is unused on your network. So that's why instead of ending at 4094, for example, I'm going to end this example at 4092 because I'll reserve two VLANs, one for unused ports and one for the native VLAN ID. So the next thing we need to do is really just finish this configuration off by telling the bond how to behave. Do we want to have network redundancy? Do we want to have higher throughput, or do we want both? Well, it really depends on what your network's capable of and what you're looking for. So the next two sections are going to cover those options. Now, one of the common reasons for wanting to combine multiple interfaces together is to give our computer access to more network capacity. So at the minute, Proxmox is only using one interface, which is capable of 1 gig. That means the overall network traffic for our virtual machines in Proxmox cannot exceed 1 gig. But what I can do is set up this bonded interface, combine two 1 gig interfaces together, and then I'll be able to get access to 2 gig instead. To do that, I'm going to copy and paste in what Proxmox themselves recommend for load balancing traffic. That's these two lines here, which I'll explain in a minute. But basically what we've now got is two interfaces, and they've been configured together as a bonded interface, a single logical interface. Now, whereas before, if we had, say, 4 virtual machines, but only one physical interface, all that traffic would have been on one physical interface. Now, because we're using this load balancing, it means the traffic's going to actually get shared. So we might see, for example, 2 of the virtual machines have their traffic on this interface, and then 2 of the virtual machines have their traffic on that interface. Overall, the network capacity is increased, and overall, our virtual machines will see a better throughput. What I will point out, though, is that one individual virtual machine connecting to another single server will not see a benefit beyond 1 gig, in the sense that if I've got a virtual machine trying to connect to a web server which is reached through the physical network, I can't get more than 1 gig of download for that session, simply because the load balancing doesn't work like that. It's balancing all of the traffic. It's looking at all the different connections between all these computers that are talking to each other, and it's balancing them between the interfaces. What it isn't going to do is it's going to look at the session between the virtual machine and the web server and then split it up between these two interfaces. So either way, one individual session from one computer to another will have a limit of 1 gig, but overall we've doubled the network capacity by combining our interfaces together. So that's just something to bear in mind in terms of expectations here. Now, what I've got is 2 interfaces, but you can have more, but you can't mix and match different speeds. So I can't have a bonded interface made up of a 1 gig interface and a 10 gig interface. I could have 4 1 gig interfaces, but that's just because they're all the same speed. If I have a mixture of 1 gigs and 10 gigs, then I need one bond that's using the 1 gigs, another bond that's using the 10 gigs. So just bear that in mind. You can't mix and match speeds. And like I said, you can have more than 2 interfaces that I'm using here, but try to keep them to an even number because that's better for the algorithm. It'll still work if you've got an odd number of interfaces, but you're better off using an even number of interfaces. When it tries to balance traffic over an odd number of interfaces, it doesn't work as well. But it does potentially work in the sense that if you've got 4 interfaces and one breaks, it'll still work. You just won't see that even balance. And in order to be able to get the most efficiency out of this, you want to be able to see an actual even balance of traffic over all of the interfaces you've got. Now, what we've done is gone with Proxmox's recommended settings for load balancing. So that is setting the bond mode to 802.3 AD, which is an industry standard known as LACP, or Link Aggregation Control Protocol. These sort of settings are pretty much the industry standard If Proxmox are recommending them, I would suggest going with them myself. I have used other settings for other sort of network scenarios, but this is what Proxmox suggests, so I'd say stick with that. If you want to change the bond mode, by all means do so. Just bear in mind that whatever you've got on your switch needs to be in sync with what you've got on your computer. So for example, let's say we put LACP on the network switch. If we configure adaptive load balancing as the mode on Proxmox, the two don't work. They've got to be similar at least. So in this case, they're suggesting put LACP as the bond mode that you're going to be using for load balancing, in which case we want LACP on the switch. Fortunately, even most of the typical retail switches out there will support it anyway, so we should be fine. The only caveat is that both of these interfaces have to be plugged into the same network switch. So what I can't do is take this switch, plug it into one, I can't take this interface, plug it into one switch, then take this interface and plug it into another switch and use LACP. It doesn't work. Unless that is, you've got high-end enterprise grade data center switches which are capable of supporting what's known as MLAG, multi-chassis link aggregation protocol. That's a pretty sophisticated switching environment which allows you to take two physical switches, for example, plug your computer into two separate physical switches and still take advantage of LACP like this. The configuration for Proxmox would still be the same, but the switches requires a lot more sophistication. So for the typical user, if you've got, say like your normal retail switches, small business users, lab users, this is perfectly fine. You would just plug your two interfaces into the same switch and that's it. The downside is it means that if your physical switch breaks, Proxmox has no longer access to the network, which, to be fair, if you're only using one interface in the first place, that would have happened anyway. You would have lost your network connectivity if that network switch had gone down. So just do bear on that in mind. You don't get network redundancy out of this. You're getting access to high throughput unless you're using these high-grade enterprise capable data center switches to support that feature. Now, the transmit policy that we're using here is layer 2 plus layer 3, which means Proxmox is going to look at the layer 2 information and the layer 3 information to decide how to balance traffic over these two interfaces that I've got. So it'll look at the MAC address, it'll look at the IP address, and it'll do some comparisons to look for differences. So where it sees different traffic flows between computers, it'll then start to split those traffic flows as best it can over these two interfaces that I've got, but that's as far as it'll go. We could go into something more sophisticated like layer 3 and layer 4, where we even start looking at the application level and start splitting even different applications over these individual interfaces. By that I'm saying if we've got a virtual machine connecting to the same computer on the physical network, and that computer is acting as a web server and an FTP server, this policy can't distinguish between web traffic and FTP traffic. Whereas with layer 3 and layer 4 it could. But what Proxmox is saying is that has a problem, at least for them, using 802.3ad, in which case they're suggesting stick with layer 2 plus layer 3. Now that is the default on most switches, and typically whatever you put on a switch you'd want on your computer as well. So again, since Proxmox suggests sticking to this along with LACP, then yeah, I would go with that as well. So all I need to do now is save these changes, and then what I can then do is reboot Proxmox itself for these changes to take effect. Now, although Proxmox has been rebooted and it's back up and running, unfortunately I can't get remote access to anymore. But that makes sense really, because we've reconfigured the networking on that actual computer and it's completely out of sync with the actual switch. Proxmox is now expecting to see LACP to bind two interfaces together. It's also expecting to see VLAN tagging. Now, how you reconfigure your network switch really depends on, well, not just the actual switch vendor, but even possibly the family of switch that you've got from that vendor. It can vary that much. So there's so many possibilities out there, so many different ways in which switches get configured, that I'll go over how I would configure it on this particular Cisco Small Business Edition switch that I'm using here. And hopefully as you follow along, you'll have a better understanding of how to configure your switch. So the first thing I need to do is to actually set up LACP. Now for this particular switch, it's really easy. I'll click on the port option. I'll then click on where it says LACP. And then I'll tick these two boxes because the computer that I've got that's running Proxmox is plugged into ports 1 and 2. So I've enabled LACP. I'm not going to bother setting a specific admin key. I'm just going to leave it to create one itself. And then I'm going to click on Save. And that's basically it. It's now enabled LACP. If I go to the LACP status option, it's saying that the protocol is active, but that's pretty much it. That's the best I can get out of this. Now, it might vary for your particular switch. So if we refer back to Proxmox, for example, we actually created a logical interface called a bonded interface, bond 0. And you might have to do something similar with your actual network switch. It might create its own logical switch using LACP, and then you use that for your configuration going forward. In my case, I just had to enable LACP on those two ports, but I just wanted to point out you might actually end up creating a completely new port, and then you start configuring that port going forward. So as an example, this switch supports static link aggregation. If I'd used that, so let's say our computer was plugged into ports 4 and 5, what I would do is create a completely new interface called lag1. And then going forward, I would do all my configuration changes on this new lag1 interface. So you might be doing something similar with your switch. In my case, as I said, I've just got to configure LACP on the 2 ports and that's it. And for me, it means I've got to now make changes to the actual physical interfaces. Whereas for you, you might be making changes on a new logical interface. So that's just something to bear in mind. But the next thing we need to do is to enable VLAN tagging. Now the next thing to do is to configure VLAN tagging on the switch. How you do that really depends on the switch that you've got. But I'm going to make some changes to this one, and hopefully that'll give you some guidelines as to what you need to do. So I'm going to click on VLAN, then I'm going to click on VLAN port settings. Now if your switch has either created a new logical interface, or it's assigned your interfaces to some built-in aggregation interface, then you'll be wanting to change the configuration of that logical or aggregation interface. Whereas for me, this switch doesn't do that, at least when it comes to LACP, which means I've got to make changes to the actual physical interfaces. And I do have to do the same changes to both physical ports. These 2 ports, port 1 and 2, which Proxmox is plugged into, have to be configured the same. There might be another setting on your switch which says that the port's an access port or a trunk port. The trunk port is used to connect to a computer that supports VLAN tagging. So if it's set as an access port, then you'll want to change that to be a trunk port. I don't have to do that. This particular switch only has trunk ports. All of the actual ports can support multiple VLANs, and there's nothing for me to tick, no box to change or anything to say, oh, we're now an access port or we're now a trunk port. They're just trunk ports anyway. So at the minute, what's going on is the switch is set up to not send tags to Proxmox because the computer that I'm using here is patched into port 8. The primary VLAN ID is basically telling the switch port what to do with untagged traffic. So when the traffic comes into port 8, the switch is putting a tag of 100 effectively onto that traffic. It then makes its way through the switch and then it would go out to port 1. When it reaches port 1, it has a look and see what the primary VLAN ID is on that port, and then it sends it over to Proxmox. Now, because the VLAN ID, or at least the primary VLAN ID for this port is 100, and the traffic that was sent to the port had a tag of 100, what the switch is doing is it's removing that tag and forwarding on to Proxmox without the tag. And that's not going to work because Proxmox doesn't know what to do with it. It needs to see a tag of 100. So what I need to do is to actually change this primary VLAN ID to be something else. So again, for your switch, it might be referenced as the default VLAN. It might be the primary VLAN ID. It might be the untagged VLAN. It might be the native VLAN. It'll vary, but you'll see something similar to this. Now, I need to use something basically that's just different to what 100 is. And that's going to be called the native VLAN. So what I really want to do as a best practice is to have a native VLAN that isn't actually getting used anywhere. So what I'm going to do is go over to VLAN settings in my case, and I'm going to select what will be my native VLAN 4093. Click on modify and tell it to allow it on those 2 ports, then click save. I'll then come back to my VLAN port settings and change the primary VLAN ID to be 4093. Then I'll click save. 4094 incidentally is my unused VLAN, so these ports here 3 to 6 aren't being used, so they're all being assigned to 4094. 4093 will be the native VLAN for me, or the primary VLAN ID if you will, so that's why I've set them to 4093. And what that means is that when this computer sends its traffic to port 8, it'll still get tagged with 100. When it gets sent over to port 1 or port 2 in this case going forward, the switch is going to have a look at what the primary VLAN ID is. Now this time it doesn't match, so it'll actually retain that tag of 100 when it gets sent out to Proxmox. But I need to make some other changes while I'm here. I'm going to select these 2 options here. Now this setting here, it might vary a bit for you. It's the acceptable frame types, and it's to decide what type of tags or no tags, if you will, that will accept from the actual computer that's plugged into the port. By default, it's set to all on this switch. Now, your switch might have an option for untagged only and tagged only and all. Mine doesn't have this concept of untagged. But because we're now setting this up as a trunk, it's a good security practice going forward to only accept tagged traffic. So I'll click on save. And again, I'm making the change in my case to both physical interfaces. I've got to keep these 2 ports in sync. What it'll mean is if Proxmox were to actually send any traffic across that doesn't have a tag, the switch will drop it. So that's a good security practice to have. Another thing I'm going to do is deselect these 2 options here. The reason for that is what this does is it forces traffic out the port to be untagged. That makes sense if it was an access port and when you've got a computer that's just plugged into the port which doesn't support any tags. There's no point sending tagged packets across to a computer when it doesn't understand them anyway. So I had that set up because originally these ports were actually behaving similar to actual access ports in a sense. They had no concept of tags, so there's no point actually sending any. So I've now made some changes to this. It might be slightly different for you. I mean, you might be able to add an interface, add a VLAN onto the actual trunk within this page, for example. In my particular case, I had to go out to the VLAN settings page and I had to modify the actual VLAN itself to tell it what ports to put it on. Whereas with some switches, you just do it on the actual interface itself. You just say, oh, you can now accept these VLANs. So it might vary, but hopefully that gives you a bit of a better understanding. So now we've made those changes, we're going to see if we can get access to Proxmox again. So at the moment it can't, so I'm just going to stop that and hit refresh. So this one has connected in. If it hasn't, sometimes what I found is just click the cross to stop the session, refresh it. Sometimes if you ping the IP address, it gives it a bit of a shove. But looking on the network configuration now, I mean, basically we've restored connectivity. But when we look on the network configuration page, you'll see we've now got a bond interface, bond 0, and there's the 2 interfaces. We've got our Linux bridge, but the IP address isn't assigned to that anymore, and the actual interface it's using is now the bonded interface. We've also now got a new sub interface, or a Linux VLAN interface as it's now referred to, and that's where our IP addressing has gone to, and also the bridge is now VLAN aware. So what this means now is I'm actually in a situation where Proxmox has got access to 2 1 gig interfaces, which means we've got access to more network capacity. We do actually have some redundancy here because if one of the network interfaces breaks, if we get a cable break, we do actually still have redundancy. What we're missing out on though is that if the switch itself breaks, well that's it, Proxmox doesn't have network connectivity at all. So we're still getting some benefits for network connectivity, but the real benefit here is we've now doubled our network capacity effectively. So our virtual machines in Proxmox can send essentially double the traffic that they could before. So just to demonstrate that actual redundancy, if I start a ping test to this computer, so that's 192.168.100.10, and I'll just set it to a permanent ping. You can see it's pinging away and it's getting a response. So I'm going to go over to the port settings on this, and I'm actually going to disable interface number 1. So now there's only one interface working. Now it always varies depending on the result. You might actually see one packet get dropped, for example, and then it'll recover. In this case, that didn't happen, but you can see we're still working even though we've only got one interface up. It's still happily responding. So I'm just going to restore that, because obviously if I disable both interfaces, it'll completely stop working anyway. So I'm just jumping from one page to another because sometimes it can take a while to refresh. So I'm still getting responses back. So I'm now going to disable port number 2. Click on save, because the response you actually get really depends on which interface we're using. But you can see here the request timed out, so it dropped one packet essentially when it was sending her a packet out and sending her a reply. It must have gone over that second interface, or it was trying to send it back on that interface. But you can see it quickly recovered. So again, now we're just operating on one link, but we're still being able to access Proxmox. So we still do have our network redundancy to a certain degree. We can tolerate a link failure, we can tolerate a cable cut and so on. But what we can't accept is a complete break of the actual switch itself. If the switch itself has a hardware failure, if it gets rebooted as part of a maintenance upgrade and so on, Proxmox would lose access to the network. But you can see it's pretty quick to recover, and the real benefit is the fact that we're getting double the bandwidth, more capacity for our virtual machines to use. Now, the most common reason for binding two interfaces together like this is to give us network redundancy. In other words, even if a network switch or a cable actually fails, we still want Proxmox and its virtual machines to have access to the network. So to do that, I'm going to copy and paste 2 lines into this configuration just to finish off the config for bond 0. So this line here is setting the mode to active backup. And what that basically means is one interface is the active interface. In other words, it's actually the only one that's operational. And then the other interface will be the backup interface. And its purpose is to just basically sit there, and if the primary interface or active interface actually falls over or loses connection to the actual network switch for whatever reason, then this secondary interface or backup interface takes over and it restores network connectivity. But we have to decide which of these 2 interfaces is going to be that active interface, or as the configuration here refers to it as, the primary interface. So the wording can be a bit confusing, I must admit. In some vendor solutions, what they have is an active passive or an active backup, a primary and a standby, and there's a lot of different ways they refer to these. But as far as this configuration goes, the mode is active backup, and then you just tell it which one's the primary interface. So basically which one is the active interface. So what this means basically is that once these changes take effect, this interface here, ENP0S25, is the interface which will be used for Proxmox to send traffic to the network and for the network to send traffic to Proxmox. This interface here won't be doing anything. It'll just be sitting there in the background, just waiting on the off chance that maybe a network switch or the network cable breaks. This one won't be able to get access to the network anymore, in which case this one will take over and it'll restore network connectivity. So I'm going to save these changes. And then in order for the actual changes to take effect, I need to actually reboot Proxmox. Now, although Proxmox has been restarted and it is now back up and running, the problem is I can't get remote access to it. I mean, I can click on links. I mean, it looks as though I've got some connection, but the reality is it's just going to eventually time out. I mean, if I hit F5, for example, or Control F5, eventually I'll actually get told that it's just, timed out. Now, the reason for that is because Proxmox has been configured to support VLAN tagging, but the switch doesn't. And the reason for that was that as part of the initial installation, we needed to be able to get direct access to Proxmox without any VLAN tagging at all, because there's nothing within the actual configuration as part of that default installation to actually set specific VLANs for the management interface, for example. This is something you have to do after the installation's been done. So in my case, I'm going to have to reconfigure my switch to actually support VLAN tagging. Now, how you configure a switch to support VLAN tagging is going to vary. It's going to be different, depending on the actual vendor of the switch. It might even be different if you've got a different type of switch, even from the same vendor. I mean, anybody who's got a career in Cisco networks, for example, knows this looks nothing like it's like an enterprise switch by Cisco, for example. But this particular one I've got, it's a Cisco Small Business Edition switch, and it's very easy to set up. It's geared towards, well, obviously small businesses, home offices, and so on. So it's pretty straightforward to configure. In this case, we just want to change over from what is an access port, which is intended for computers that don't support VLAN tagging, over to a trunk port, which is for computers that do actually support VLAN tagging. So what's going on at the minute is that this computer, which is plugged into port 8, is sending its traffic into the switch. And because the actual switch has been set up for an access port, in this case, as I'll refer to it as, it's actually putting a tag of 100 onto that traffic as it goes through the switch. And then when it gets to port 1, it has a look at this heading called the PVID, the primary VLAN ID. It sees that it matches 100, and then what it does is it removes the actual tag. Now, what I need to do is to actually change this to something different. I need to actually retain that tag, but how you do all this really depends on your actual vendor. So for example, you might actually have a column in here, for instance, on your port, which actually says if it's an access port or a trunk port. If it's configured to be an access port, you need to change it over to a trunk port. That's how we'll be able to support the actual VLAN tagging going forward. Now, for this particular switch that I've got here, it doesn't have that concept of access ports or trunk ports. Everything is a trunk port. You just keep adding VLANs to it. Now it refers to this column here as the PVID, the primary VLAN ID. Some switches will refer to it as the default VLAN. Some will refer to it as the native VLAN. This one just calls it the primary VLAN ID. But the principle is the same. Basically, it's the VLAN that you actually use for traffic that doesn't have a tag. In other words, the intention is, like in this case for this particular computer, for example, it doesn't support tagging, in which case the switch needs to actually add the tag. And likewise, if you're going to be sending traffic then back out to a device that doesn't support it, we need to know which VLAN ID to actually remove at the end. So, like I've said, the problem I've got at the minute is that I've got a computer in VLAN 100, I've got Proxmox supporting VLAN tagging, and as far as the switch is concerned, any traffic that's destined for VLAN 100 should have the VLAN header removed, but I need to keep that. So I need to change this setting to something other than 100. Now to do that, I need to actually add in an extra VLAN. So it's going to vary depending on your switch. With some, you just reconfigure the port, add VLANs as you go along. For this particular switch, I've got to actually modify the VLAN itself and assign it to port. So I'm going to go over to my VLAN settings here, and I'm going to pick this VLAN 4093. This is going to be my native VLAN. The idea is this is an unused VLAN. I don't want it to be actually getting used. I don't want any computers using it. So I've picked out this specific VLAN. It's also why I've got Proxmox not using it. 4094 incidentally is for my unused ports. So any port that isn't in use will get assigned to 4094. Again, the idea is other computers out there, if they accidentally get plugged into a port that's not in use, there's nothing actually to connect to really. But in this case, I need to assign 4093 to port 1. So I'll click on save, and that makes a change there. I'll go back to this port, and I'm going to change the primary VLAN ID to be 4093. So the idea now is that when my computer sends traffic to port 8, the switch is going to add on a VLAN of 100, and then when that traffic makes its way over to port 1, it exits out the interface, and then the switch will say, all right, well, 100 doesn't match the 4093, which is the native VLAN, the default VLAN, the primary VLAN ID, or whatever your switch refers to it as, in which case it actually retains that heading of 100. So it comes in without any tag, but exits with a tag. Another thing I'm going to do, just for security reasons, I'm going to set this setting here, which is the acceptable frame type, to tagged only. And what that means is that going forward, we'll only accept traffic from Proxmox that has a tag. So that's a security feature. We're expecting tagged traffic, so we should set this to say we only expect tagged traffic. On some switches, they'll have a setting for all untagged or tagged only, in which case you've got more options than I've got here. For me, it's just either all or tagged only. But I do want to set it to tagged only because I don't expect any untagged traffic from Proxmox. Therefore, I should actually be dropping it. Another setting I need to do is to disable this feature here, which it forces traffic out of the interface to be untagged. It makes sense if it's an access port because it's not expecting any tags, but now that Proxmox is expecting tags, I need to remove that feature. So we'll go back to Proxmox, click around, and you can see I've actually now got access again. And that's just because I've updated the actual tagging. So the switch is now supporting tagging. Now, what I need to do is, I've actually got two switches because we're setting this up for redundancy. So I need to repeat the same process on switch 2 here because that's not supporting that feature. One thing I'll point out is that these two switches are linked together, they need to be. That gives me my redundancy. So the idea is interface 1 plugs into this switch on port 1, interface 2 plugs into this switch on port 1, but I've got a link between the two switches. So my computer, which is on switch 1, is getting access to the actual computer here through switch 1, going over to switch 2, for example, to get access to interface 2. So that's something to bear in mind, is my computer doesn't have redundant access, but Proxmox does. But you would have to have that link in between, the trunk link between your two switches, for all your computers to have access to each other regardless of which interface they're on. So I'm just going to finish off the configuration on switch 2 here, and then we'll test out our redundancy. Well, switch 2 has now been reconfigured. So they're both configured in exactly the same way for port 1, because port 1 of Proxmox is plugged into port 1 of switch 1, and its port 2 is plugged into port 1 of switch 2. So we'll just have a look at the network configuration now. If we go to System and then to Network, you'll see we've now got a bond 0 interface, which is made up of our two physical interfaces, and the mode is Active Backup. If I select that, click on Edit, you can see here where it's been configured so that ENP0S25 is the actual primary. And then we've got our two physical interfaces. Our Linux bridge is still here, but now it's VLAN aware, and it's referencing bond 0 now instead of originally ENP0S25. And then we've got a new interface, the sub-interface or VLAN interface called VMBR0.100. So this is our new management interface. So it has the IP addressing that was originally assigned to the bridge itself. And what that means is that going forward, Proxmox is tagging traffic for this management network with a VLAN of 100. And it's expecting traffic for this management interface to be tagged with a VLAN of 100. So we've now got our VLAN set up. All our VLAN tagging is now working, and Proxmox itself is VLAN aware. We can actually assign virtual machines with VLANs. We can create new interfaces for Proxmox in new VLANs. But what we want to test out next is actually the actual redundancy. Does it actually work? So I'm going to open up a command prompt, and then what I'm going to do is I'm going to start a continuous ping, because at the moment this interface is the only interface that's actually doing anything. The other one's just sitting in backup. That's the expectation. So I'm going to ping Proxmox. In this case, it's 192.168.100.10. And I'm going to set this up as a continuous ping. And that's how we do that in Windows, just by putting on a -t as a parameter. Hit return, and you can see we're getting responses back from Proxmox. So I'm going to go over to switch 1. I'll go up to port and then port settings, and I'm actually going to disable interface number 1 from the switch. So this is sort of like the equivalent of a network switch failure, basically, or a cable failure. Now, I can't literally fail the actual switch itself, because then my computer wouldn't be able to get access to Proxmox at all. So this is like the closest I can get. As far as Proxmox will be concerned, that interface has suddenly disappeared. So we can see it's timed out. Sometimes it does, sometimes it doesn't. It just depends on how quickly it can recover. But it's basically what it's done now is that this interface here will have gone down. And then what it's done is then brought this interface up and made it more active, essentially. So what we've now got is a situation where instead of actually sending traffic backwards and forwards on this interface, we're now using that interface. But the key thing to point out is only one of these interfaces is ever active at any given time, and that's what we want, really. Otherwise, it causes a lot of confusion. There are other modes you can use. Switches and network administrators, they don't like it if you've got 2 active interfaces on 2 different switches. The MAC address starts jumping around, and it causes all sorts of problems for management, and you just don't want to do that. So if you're interested in network redundancy, then you want 1 active interface and 1 standby interface, or as Proxmox calls it, and 1 active and 1 backup. Anyway, what we're going to do is we're going to restore this interface back again. So I'll click on save. I just need to click away and then click back, and then eventually the link will come back up again. So that's now back up again. So you might get we've got a bit of a disruption again. So basically what Proxmox then does is it then disables this interface and then restores this interface. So like I say, there's only really 1 interface is actually being used. It says they're both active. It just means as far as the system's concerned, yeah, they both have the potential to be used, but as far as Linux is concerned, it's a case of there's only 1 interface actually being used at any given moment. But it means that we've got full network redundancy. So if this actual interface were to lose connection to the network, so it could be a cable failure, it could be a switch failure, maybe the switch is undergoing maintenance, getting a software upgrade and it's rebooted. For whatever reason, if this particular network interface is actually losing access to the actual network, the operating system, Linux here, is actually detecting that, and it'll switch over to the other interface. Now, like I was saying, I mean, although I've got 2 switches, I've only got 1 computer which is plugged in when I'm doing my testing with, and it's only plugged into 1 switch. So I can't genuinely simulate a complete switch failure, but the principle would be that all your computers would all be plugged into both switches, and it wouldn't matter if a switch failed, they'll all be able to still get access to each other. So pretty straightforward to set up. And the next thing is to start looking into providing Proxmox with its own VLAN interfaces in different VLANs, so it gets direct access to other networks, as also how to actually do the VLAN tagging for the virtual machines. Now, it doesn't really matter which of these methods you're using, whether we've got 2 interfaces that are bound together like this as an active backup, or we've actually got multiple interfaces bound together to give us higher throughput. What we do going forward is basically the same. If we want to be able to give Proxmox access to another network, so for example, let's say we want direct access to a storage network, we don't want to be sending our traffic through a firewall because it slows down, so we have a dedicated VLAN which gives direct access into a NAS, a SAN, whatever that storage device is. It means we need another interface for Proxmox. There's nothing beyond that actual network. It's an isolated network. All the actual Proxmox will get access to is the actual storage device, but we need to create a new interface on Proxmox. Now, you could actually go back into the configuration file if you want, but you can also do it through the actual GUI here. So what I'm going to do is I'm going to click on create up here, and I want to create a Linux VLAN. Now, I've got another VLAN which is VLAN 200, so I'm going to keep in sync here, so it's VMBR0, if I can type properly. So that's our bridge, but this time I want to reference VLAN 200, and you can see automatically it's populated the VLAN tag of 200, so it's saying that the raw device is VMBR0, in other words the Linux bridge, and it's VLAN 200. Now I'm going to keep things in sync here, so its IP address will be 192.168.100, 200 rather, 10. You don't have to do what I'm doing here, which is to keep the third octet in sync. I mean, once you get into actual large networks which have got thousands of VLANs, it's just not practical. You can only go from 0 to 255, for example, so it's just not practical. But in this case, it's a small network, so I can get away with that. So that's its IP address, and then we've got to give it its actual subnet mask, or side or length in this case, how many bits make up the subnet. And then that creates a new VLAN interface. So I'll click on create. Now, as you can see, it's not active. We actually need to apply the configuration. So I'll click on apply and say yes. And then off it goes. Now, this is just going to reload the configuration, the network settings in the background, which means we don't have to actually reboot Proxmox itself for this to take effect. One thing I'll point out, though, is that I did not assign a gateway to that interface. And you don't want to, especially when you've got firewalls in your network. You would only ever have one interface that has a default gateway, like this one here. Otherwise, it causes confusion. It'll start to load balance traffic between multiple interfaces, and if you start hitting firewalls, you'll start to find things break. You get intermittent outages and so on. It just causes all sorts of pain, basically. So all you want to be doing is setting one interface with a default gateway, like this one here, for example. Everything else, do not give it a gateway. In this particular case, this is fine. Let's say 200 is our storage network. There's nothing beyond that VLAN anyway, so it doesn't make sense to give it a gateway anyway. So we've now created our actual VLAN interface on Proxmox, but we need to actually allow access to that VLAN, because what we did when we set this all up was we allowed pretty much every VLAN on the actual trunk for Proxmox, but not for the switches. So we actually need to update the switches so that the actual Proxmox server actually has access to 200, because at the minute, if Proxmox were to try to send any traffic tagged with 200, the switch interface isn't actually configured to support it, and it'll just ignore it, and that's a good security feature. So I'm going to go over to my switch, go to VLAN settings. I need to log back in again. And what I need to do is to actually allow VLAN 200 to that specific port, because it's a good security practice. Only allow access to VLANs that a computer should get access to, and by my doing that on the actual switch, it just makes the administration easier. I only need to update the switch and up the switch and Proxmox, but in this case I'm going to have to do it on both switches, because if I forget to do the second switch, the problem you'll find is that if the primary switch failed or Proxmox just lost access to it, and the secondary switch didn't support access to VLAN 200, then things wouldn't be working anymore. So you've got to remember to do it for both when you've got an active passive interface like this. Likewise, if you've got a switch that's got multiple interfaces being used by Proxmox, again, you've got to update all of the physical interfaces. If you were doing it on a switch like this, if it's a logical interface, it's easy, you just update the logical interface. But in this particular case, if I go and have a look at the list here, we've got a range which includes 200. If we go to this one, that one includes 200. One thing to point out is I'm not changing the primary VLAN ID, that's just the native VLAN. Once you've set that, you just leave it as is. Now this particular computer, it's 192.168.200.10. So I'm just going to stop my ping actually, because I don't need that anymore. Assuming it'll let me. So if I now try to ping 200.10, you see I'm actually getting a reply back. And the reason for that is this computer does actually have two interfaces. One is plugged into port 8, which is assigned to VLAN 100. The other is plugged into port 7, which is assigned to VLAN 200. So the computer's actually got access to two VLANs, but it allows me to test and just demonstrate how I can set up an extra interface on Proxmox in another actual VLAN here, in this case 200, and show you that in my case I've got a computer on the physical network getting access to Proxmox, and it can do it in both VLANs now that we've set it up like this. So the next thing to do is to go over how to set up the actual virtual machines to get access to VLANs. Now, because Proxmox and our network switch are VLAN aware, in other words, they're exchanging VLAN tags, we need to make sure that our actual virtual machines are actually tagging their traffic with a correct VLAN. So what I'm going to do is I'm going to select this virtual machine over here, and then I'm going to go to hardware. Now, we then need to pick an interface that we want to change the VLAN tag on, because by default it doesn't do any tagging at all. Now, in this particular case, this specific virtual machine has only one interface, but if it's got multiple interfaces, you're going to have to put each of them into their own proper VLAN. I mean, typically you might have like a server, for example, running as a virtual machine, which has like a management interface, for example, or a storage interface. Maybe it's got a completely separate backup interface, a front-facing production interface, and so on. But in this case, the principle is the same. The idea is just select the interface, click on edit, and then where it says VLAN tag, we put the actual VLAN number that we want to tag the traffic for this interface with. So in this case, I'm just going to use 100. I'll then click on OK, and then I'm going to start this virtual machine up. And basically what this means is that going forward, this virtual machine will start tagging traffic on this interface with the VLAN 100. So it'll be able to get access to other virtual machines within Proxmox, for example, that are also in VLAN 100. It should be able to get access to any device reachable through the physical network on VLAN 100, as long as the network switch supports VLAN 100 on the interface. I mean, the way we set up Proxmox itself, it supports anything from 2 to 4092, for example, so we've got a lot of flexibility. One thing I'll point out, though, is that your virtual machines can be in different VLANs to Proxmox. I don't necessarily have to add a new VLAN interface to Proxmox just to get a virtual machine access to it. So for example, let's say I want an interface in VLAN 300. I don't have to create a VLAN 300 on Proxmox. I can tag that traffic as VLAN 300 on the virtual machine. I just need to make sure that the actual switch supports VLAN 300 on that interface as well, or rather all interfaces, or in this case, both switches would need to support VLAN 300. So that's just something to bear in mind. We've set Proxmox up to support a wide range from 2 to 4092, or it could be 2 to 4094 if you've gone with Proxmox's own suggestion. But it's a case of you do not have to have Proxmox in a VLAN that your virtual machines are. There's no specific need for it. Anyway, I'm going to go back to my virtual machine. I'm going to see if it's up and running now. So I'll just click on console. And I'm going to log into this one because I need to find out what its IP address is. Because the idea is I want to see if I can get access to the physical network from this virtual machine. And likewise, if I can get access to this from the actual physical network as well. So I'm just going to select the menu option there. Just open up a terminal session. Find out what its IP address is. So this is .50. So if I ping 192.168.100.12, I think the switch was. So it's getting a response back from that switch. There isn't a 14. The other switch is 13. Proxmox itself is 10, so it's getting a response back from Proxmox. So if I try to ping 100.50, so my computer gets a response back, which is to be expected anyway, because if this computer can get access to something on the physical network, something on the physical network can get access to this. The reason being is that this, out of the box, this is a Linux computer. It doesn't have a software firewall active on it. Windows does. So, for example, I can't ping my Windows computer from this Linux computer just because it's got a software firewall and it'll drop the traffic. So that's just something to bear in mind. But now that we've got the tagging enabled, I mean, I can create other virtual machines on Proxmox and put them in the same VLAN. I could have other computers anywhere that's got connectivity through the network on VLAN 100, and they'll all be able to talk to each other. So it's, again, pretty straightforward. You just need to update the VLAN tag, but just remember that you need to do that for every interface if your virtual machine has multiple interfaces. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.